Stats Lab, and I have a publicly accessible version of that. And so I'm just going to show that. I'll post a link for y'all. It will look something like this. So I'll post a link that brings you to part of my stats course. This is the publicly available part. I have different announcements than Pete Hernberg will. Here's one I put about percentile rank, and then there's another one down here about how to do histograms with some videos and some other tips. At the bottom is the Stats Lab. You click that, that pops up a new window. And here I will post information for each lab. And so I have, here's that link to that live hangout. So if I click that, see, I can't click that because I am Gary Parker. So let's copy that address and go in as an anonymous person. So you get this right here, and it will say something like, if you go to play it, it will say this will start in whenever. And once it starts, it will go live. And then I'll send you another link that lets you join the broadcast. And then we can interact. So we'll be using that in the future. And so each time I do one, you'll get a new invitation and then a new link for that live broadcast. So notice this is Stats Lab 2, so next week will be a Stats Lab 3, and so on. And after we do it a couple times, you get used to it. I prefer Google Hangouts over things like Zoom or Collaborate because it takes the videos straight to YouTube, and they're freely accessible to anybody in the world. And sometimes I do good broadcasts, and sometimes they're kind of weird like this one. Anyway, let's play with some data. So I have some data for you. Lab 2 data right here. So this is linked in that MyOpenMath page that you're going to go to. And one thing you want to do once you get it, it says view only. You want to either download it and play with it in Excel if you prefer Excel. I prefer Google Sheets. So what I would do is I would go to File, make a copy. And then that will allow you to name it so you can give it a better name, like maybe your name is Bo. Bo's Lab 2 data. Then you can click OK. Once you do that, it'll make a new copy, and now it's fully accessible to you. You can use all the features of Google Sheets. And then I would do something like File, Organize, and I would put it in a folder. So I'll move it somewhere in my drive. That makes sense to me. Like, for example, I have a folder for math stuff. Math 243, and so I can put it in there so it's easy to find later. So then we're going to edit the data. So what are we going to do with the data? Well, we're going to review some statistics that you covered before. Those of you in Hermiston, you haven't quite covered standard deviation. We're going to do it anyway, so you're going to learn about it ahead of your classmates. So for this data, I need to find the min, Q1, the median, Q3, the max. I also need to find the mean of my sample, and I need to find the standard deviation. Once we get those, we're going to do a few different things. We'll extend the interquartile range, the distance from Q1 to Q3, to look for outliers. We'll also find out which numbers, so by the way, these are temperatures of humans I measured. And I have 520 of them in this list. That's a lot, so we can't easily go through this by hand, so we have to use the computer to help us. To verify there's that many, I could use the count command. So I could say equals, start typing count. There's a few different options. We'll use the count if later. That's pretty cool. So we're going to use count, tab to complete it, highlight the data. If there's only numbers in that column, you can just click the column heading. It will then say all of column A colon A. Otherwise, you would select a group, and then down here it'll say which cells you selected. So maybe you selected cells A1 through A520, which I believe is the size of my data set. So I'm just going to go back to the A column A, And again, you got to be careful with using the whole column, because if there's other stuff in the column, that's going to mess up the computation. So use that very carefully. Ooh, this says there's 521 things. I swear I only had 520. Yeah, so I measured myself the other day and added that to the list. It's a mystery. Let's check. Oops, I scrolled back. I'm getting close. Oh, check it out. There's an extra number in there. What is that number? I found the average value of the column. So that's going to mess up my data. So see, I clicked the column. There was something else in there I forgot about. That's going to severely mess up my other computations. So I'm going to leave that number down there. Whenever you do a calculation, you should always put a comment nearby explaining what it is. So we're going to go back to the top and redo. So page up and up. All right. So I can't do the count command the way I did. Instead, I'm going to have to highlight all of the cells. Give me a few seconds to get down to the last element. It'll usually slow down near the end. If you can scroll too far past it. Okay, I need to go right to there. Then close the parentheses and hit enter. Now, for future reference, since I'm going to be grabbing that data all the time and scrolling down is a pain in the butt, I can just highlight up here, Control-C to copy the range of numbers I need. So then when I do something like I go min, I can just paste Control-V on the keyboard. V as in Victor or Vampire. Close parentheses, enter. Q1, quartile, tab, complete the command. Paste in the data selection, comma, first quartile, close parentheses, enter. Equals, median. If I'm moving too fast, you can always pause the video. Back it up, try it again. Equals, quartile, tab to complete it. Paste in the data. I want the third quartile. Close. Max. All right, already got the count. X bar. So that's average. That one right there. So if I can use the arrow keys on the keyboard to move through the selections. Cell does that too. Tab to complete the correct one. Paste in the data. Standard deviation. Talk more about where that comes from in class. ST for standard, and then I get a whole bunch of options. So STDEV, the first one, finds the standard deviation of a sample, which is what STDEVA does too. STDEVP is an entire population. Generally, we'll have a sample, not the whole population. So we would use STDEVA. I imagine soon the command STDEV will vanish from places like Excel and Google Sheets. That was the old command, placed it with these new versions here. The PA, P, and A. So I'll go with the new one, A. Tab to complete it, paste in my data, close parentheses, enter. All right. Other things I want to figure out. I want to figure out, so again, what does standard deviation tell me? Standard deviation is a measure of the average spread of the data. That's one way you could think about it. We use it as a measuring stick to talk about how far are you from the middle. So for example, somebody who measured 98.3 for their temperature. Let's use a different one. Let's go 99.4. They are not the same as the average. Now, generally, when we do calculations like these, we take it 1 to 2 decimal places more than whatever is the significant figure in the data. So here we have a 10th in the data. We should take this to 100th or 1,000th. Different books, different statisticians have different philosophies on that. So I'm going to take this to the nearest 100th. I believe our book says take it to the nearest 1,000th. So then I can use the decrease decimal button up here to drop it down. And let's go there. That's enough. So if let's suppose the 99.4, that was my temperature, let's say. So I'm going to highlight that one just for fun so we remember it. I am not average. How far from average am I? Distance from average. Distance from average is referred to as your deviation. How far do you deviate from the center? Deviation, I think I spelled that right. So to calculate my deviation, I take my score and I subtract the mean. And now I get a positive 1, so that means I am 1 above. Somebody that measured, say, 96.5, right, so if we found their deviation, let's do that one instead. Replace A10 with an A4. They are below the mean, so they have a negative deviation. So positive deviation means above, negative deviation means below. Deviation is distance from the mean. That's always found by taking your measurement, we call that x, and subtracting the mean, whether that's the population mean or the sample mean. So that's how we calculate deviation. So let's put a little equal sign in front of that. Okay, so that's my deviation. Standard deviation gives us just an average amount of deviation to measure by. So notice that I am more than the standard deviation away. An average deviation is about 0.7 on this data. Mine is 1.2. So I am like, I don't know, almost 1.5 standard deviations away from the middle. So to count how many standard deviations away I am, I just take my deviation and divide into it the standard deviation. And then that says, Gary, you are about 1.43 standard deviations from the mean. So let's change the decimals on that. So Gary is 1.43 standard deviations from the mean. That idea right there is known as a z-score. But we'll go over this with you soon. We're going to use it today. So what I want to do is I want to calculate which numbers in my data are 3 standard deviations to the left, 2 standard deviations to the left, 1 to the left, 1 to the right, 2 to the right, 3 to the right. And it turns out those are valuable measuring points. So I just type equals, take x bar, my average, subtract 3 times standard deviation. Whoa, that's not a 3. Let's repeat that for each one down here with the correct calculation. Always do equals first, click on the number you want on the screen, minus 2 times the standard deviation. And then I want to go find the number on the screen, go equals first, minus 1 standard deviation. And then go the other direction. Take the mean and add a standard deviation. Mean, add 2 standard deviations. Got to put that times in there, otherwise all hell will break loose. And the mean plus 3 standard deviations. And normally what you'll find with most data is that pretty much all of the data, 99% of it, will be between 2 standard deviations. Not all data is the same, right? So we'll have all kinds of different spreads, distributions. So sometimes we'll find that there is sometimes quite a bit of data outside 3 standard deviations. Sometimes we'll find data where almost all the data is within 2 standard deviations. It just depends. So I could do things like I would want to count up how much of my data is within 1 standard deviation of the mean. So I'm just going to play around with some ideas about that. Move this stuff out of the way. Let's put you up top. Some room right there. All right. So I want to count, for example, how many data points are less than or equal to this number right here. How much of my data is less than 99.10? So to do that, I use the count if command. So I go count, and then I arrow up to count if. Count if says, okay, where's your data? Well, remember, we copied that A1 colon A520 is where my data is. And then it says, what are you going to base the if on? So I only want to count data if, and they tell me how to type it here. Parentheses, if my data is less than or equal to, and then I type my 99.1. 99.1. Close that. And then I hit enter, and it says there are 442 of these 520 numbers are less than 920. Let's do that same thing for this one right here. So count if. Count if. I paste my data in, comma, and then I want to know if my data is less than or equal to 97.67. 97.67. Clear parentheses. And so there it says, oh, there's none. Did I type that right? That can't be possible. I must have mistyped something. Oh, I put an extra parenthesis in there. Darn it. Okay, there we go. All right, there's 69 of them. All right, so if there's 442 below this number, and there's 69 below that number, if I subtract those two numbers, then that should mean there are 373 of them between one standard deviation on each side of the mean. I'll show a graphic later that'll help illustrate that. Actually, no, I'll show a graphic right now. This is an idea related to a normal distribution. Some images of normal distributions, and let's take, how about, I like this one right here. And let's blow that sucker up. Blow up. Oh, stop it. Okay, let's try this. Open image in new tab. And then blow it up. There we go. Okay. So what we're doing is our data has some distribution if we made a histogram. Maybe it's nice and symmetric like this, but blocky, maybe not. So what I'm doing is I'm looking for any number that's, remember my mean is what, 96.4-ish. And then one standard deviation to the right was 99.1 and 99.7-ish is on the other side. So here's 99.7-ish. Here's 99.1, in the middle is 98.4. So I'm trying to find out how many numbers live between here and here. And if it's normally distributed, we should find about 68%. So let's see what happened here. I found there were 373 of them within one standard deviation. So let's write that underneath, within one STD. What percent is that of the data? Well, if we take 373 and we divide by that there's 520 numbers, I calculate that about 72% of my data is within one standard deviation. That's not bad. That's kind of close to 68. So I can repeat that idea for two standard deviations here and here. So let's highlight those two cells. Color, let's make it pinkish. And then let's do the count if there. So equals count if our data is, quote, less than or equal to 99.81. Close, quote, close parentheses. And 514 of them are at or below 99.81. On this side, do my count if in my data range. Notice highlighting A1 through A520 takes a few seconds. It gets annoying if you do it 20, 30 times. So remember I copied earlier A1 through A520, Control C, so that I can paste it in my formulas. And then I want to know, for quote, if that is less than or equal to, in this case I want the two standard deviations below the mean is 96.96. It's a cute number. close quotes, close parenthesis, and if any quote or anything's out of place, Excel gets all confused or Sheets gets all confused. 18. So let's come down here and go equals the upper number minus the lower number. So we find that there are 496 of numbers in between. Check that as a decimal. What is 496 divided by 520? We get that's about 95%. So let's hit the percent button on that. And these numbers represent within 2 STDs of the mean. 95% of the data. So it turns out this is called the empirical rule, these percentages. If about 68% of your data is within 1 standard deviation, if within 2 standard deviations of the mean you have about 95% of the data, and within 3 standard deviations you have 99%, then we say the data appears to be normally distributed. Also, you should have a bell-shaped histogram. Let's check that quick. I'm going to stop this recording. So Google Sheets does a way better job at histograms if you use the quick histogram button. Where's the quick histogram button? Glad you asked. To use the quick histogram button, you don't worry about a frequency table. You just highlight your raw data. So let me go down here and grab all these numbers. Grabbing numbers. Slow down. Oh, whoa, get back. Oh, there we go. Got them. Okay, highlight your numbers. Then go to Insert. Then you go to Chart. And Excel will say, would you like a histogram? Look at that. Holy shit, that was quick. Say, yes, I want a histogram. We could clean it up a little bit by going to Customization, putting a relevant title, like body temps of people in Eastern Oregon. I measured these in Pendleton and Hermiston. I did go up to Walla Walla once. And I went to Tri-Cities once too. Okay. So in, let's just say people. All right. It's got a legend here for the color. There's only one color, so I don't need a legend. So I'm going to switch that to none. And then I probably, let's zoom out a little. I probably should label what these numbers mean at the bottom. So if I scroll down, it'll let me omit the dividers. Nope. Bummer. I can always change the bucket size. So it looks like it picked a bucket size of what? 96.45 up to 96.75. So about 3/10 of a degree Fahrenheit. So I could say, yeah, what would it look like if I went with 5/10? It'll draw me a new histogram. And so I can mess around and find one I like. Ooh, it wasn't 3/10, it was something else. It's right in my head. So if you eliminate bucket size, it'll go back to what they picked. So if you like what Excel Sheets picked, great. Excel doesn't do an automatic histogram, unfortunately. We have to make a frequency table first. Let's see, 0.45 to 0.75. It's 0.3, isn't it? I'm not sure what happened there. Anyway, some other things I might want to do is put a title at the bottom and say that's degrees Fahrenheit. So I can spell Fahrenheit today. Fahrenheit, that's right. And then I could switch from horizontal to vertical and put a label here if it's not obvious to my readers. So maybe it's not, so I'll say that's the frequency. And I think that's good. Zoom out again so I can hit Insert. And there's my roughly bell-shaped histogram near the top. Move it away from my data. Actually, I think I'm going to move it to a new sheet. So there's my histogram. I can always adjust it by going to Advanced Edit again. And if somebody or I didn't like the bucket size later, I could change the bucket size to something else and get a slightly different histogram. I can play around until I found something I like. All right. And if I like it, I hit Update, and there's my new histogram. So back to sheet 1 here. So this is what we're going to go over in lab today. If for some reason our live session didn't go well, we have this video as backup. That's it for now. Take care, stay in touch, do good math.